Good morning. It's November 5th and this is your daily brief in science. Here's everything you need to know. A new UNEP report shows the world is on track for roughly 2.3 to 2.5 degrees Celsius of warming this century if current plans are fully kept, and pledges still fall short of Paris goals. The analysis also notes that U.S. policy shifts under the Trump administration could add about 0.1 degrees of warming, offsetting some global gains and pressuring other nations to tighten reductions. In 2024, global emissions rose about 2.3%, led by increases in India followed by China, Russia, and Indonesia, with the G20 responsible for around 75% of emissions. The EU was the only major economy to cut emissions. The report emphasizes that action must accelerate to protect livelihoods and avoid irreversible damage. It also highlights that ambitious climate action offers health and economic co-benefits, while vulnerabilities to heat and sea level rise persist in communities and ecosystems. Proven solutions exist, including rapid deployment of renewables and methane reductions, which could deliver growth, jobs, health gains, and energy security if pursued aggressively. Every fraction of a degree matters, with risks including tipping points such as the potential irreversible loss of the West Antarctic ice sheet. The piece explains ICN's mission and funding model, noting its nonprofit status and commitment to free, independent climate journalism. Implementing faster cuts will require navigating geopolitics, substantial support for developing countries, and a redesigned international financial architecture. Climate action is framed as a national interest, not philanthropy, with immediate deep cuts described as the only path to avert extreme events and irreversible damage. Experts observe that the fossil fuel industry's responses to rapid energy transition are evolving as clean energy economics become more viable, while reductions in temperature are linked to fewer deaths and economic losses, with solar and wind expanding, including gains in Portugal. A rare cosmic beacon has lit up the universe, revealing a superflare from a black hole that is over 10 trillion times brighter than the Sun. This event, nicknamed Superman, is the most luminous light burst ever detected from a black hole and comes from a tidal disruption event observed over years from Earth thanks to time dilation near the event horizon. Researchers published their findings in Nature Astronomy on November 4, 2025, led by Matthew Graham of Caltech, based on long-term survey data gathered by the Zwicky Transient Facility and the Catalina Real-Time Transient Survey at Palomar Observatory, with initial recognition in 2023 after distance calculations. Early observations in 2018 were inconclusive, but 2023 spectra from Keck Observatory revealed extraordinary brightness, and infrared data from WISE helped rule out relativistic beaming as the cause. The results illuminate how supermassive black holes interact with their galactic environments and how such extremes form in the early universe, while emphasizing that this discovery relied on sustained survey data and ongoing observations to determine how common ultra-bright tidal disruption events are. The leading hypothesis involves a chaotic encounter that sent a star skirting the black hole, triggering a tidal disruption that produced this unprecedented flare. Experts stress the need to distinguish these events from intrinsic active galactic nucleus variability and view this case as a crucial data point for tidal disruption physics and active galactic nucleus environments. Independent scientists, including Joseph Michael of the Harvard-Smithsonian Center for Astrophysics, underscore the significance for understanding galactic nuclei and black hole activity. Observations were conducted at Palomar Observatory, and the team notes that initial skepticism about energy measurements gave way to a clearer picture as data accumulated. Researchers also suggest that stars in active galactic nucleus disks can grow larger via accretion, potentially enabling such colossal tidal disruption events, and anticipate finding more through ongoing Zwicky Transient Facility monitoring and future Rubin Observatory data. A 3-marker blood test could sharpen heart attack risk prediction by combining lipoprotein A, remnant cholesterol, and high-sensitivity C-reactive protein. In a study of over 300,000 UK biobank participants followed for a median of 15 years, risk rose stepwise as these markers rose, with all three in the top ranges nearly tripling the risk. 2 elevated markers doubled risk, and one elevated marker increased risk by about 45%. Each biomarker reflects a different pathway: genetics and arterial blockage, LPA, cholesterol metabolism remnant cholesterol, and systemic inflammation high-sensitivity C-reactive protein. Tests can be run with available lab measures for LPA, and high-sensitivity C-reactive protein and remnant cholesterol can be calculated from standard lipid panels, potentially making the approach accessible in routine care. The findings suggest these biomarkers together capture genetic factors, inflammation, and cholesterol abnormalities better than any single marker. Clinicians may consider these results alongside genetic risk scores and coronary artery calcium scans as part of a broader risk assessment toolkit, while weighing cost and insurance coverage. Guidance from risk calculators and guidelines, such as PREVENT, may support integrating biomarker information into shared decision-making for preventive therapies. However, the study is observational and based on an abstract. It remains preliminary until peer-reviewed publication, and generalizability to diverse populations needs further confirmation. Elevated results were defined as the top 20% for each marker, with analyses adjusting for conventional risk factors. Experts acknowledge cost and coverage barriers, but note growing evidence and treatment options that may make biomarker testing increasingly relevant in preventive cardiology. 3I/Atlas has re-emerged from behind the Sun after its perihelion at about 1.4 AU, and ground-based telescopes are now able to observe it again as it moves on a northern upward path. Astronomers and NASA continue tracking the interstellar visitor to study an object from another star system, with several large telescopes joining observations in the coming days. Early data suggests the comet brightened rapidly before perihelion and appears bluer due to gas emissions, indicating ongoing gaseous activity as it moves away from the Sun. While public speculation about aliens has accompanied some discoveries, scientists emphasize sticking to data and rigorous analysis. The comet's unusual composition offers clues about material from another star system and the early solar system, reinforcing the scientific value of interstellar objects. Radio observations around perihelion are underway, with hints of earlier optical reports awaiting confirmation. A morning-twilight observing window exists due to the northward motion, and the Lowell Discovery Telescope is among the facilities set to observe post-perihelion, with amateur observers reporting visibility about 16 degrees from the Sun under good conditions. Future observations aim to track how the icy surface sublimates into gas as 3I/Atlas recedes, helping determine its composition and structure. Researchers expect continued insights into the comet's makeup through monitoring gas emissions and surface changes as it moves farther from the Sun. Despite public speculation about alien origins, most astronomers regard 3I/Atlas as a regular interstellar comet and potentially one of the oldest visitors detected. New analyses suggest the object may be billions of years older than the solar system, with a surface crust shaped by space radiation, and some assessments contend it could be the oldest known solar system visitor from a different stellar region. The rapid pre-perihelion brightening and blue-tinge spectrum from gas emissions underscore the ongoing need for observations as the comet brightens near closest approach on October 29th. NASA imaging remains challenging due to the comet's small size, rapid motion, and solar glare, while the Lowell Telescope and other facilities plan to broaden data collection post-perihelion. Amateurs have reported visibility, and the Lowell Observatory Discovery Telescope captured what's believed to be the first optical post-perihelion image. 3I/Atlas stands as the third confirmed interstellar object detected in our solar system, following 1I/Oumuamua and 2I/Borisov. The United States is racing to build a domestic rare earth magnet supply chain, with a strong focus on recycling and end-of-life material recovery as China tightens export controls. Policymakers want to restart mining and processing while boosting recycling to create a more resilient, independent magnet workflow for defense, energy, and technology. Design for recycling and standardization are seen as essential to improve disassembly, standard magnet sizes, reduced adhesion, and clear material identity, which lowers costs and improves recovery. High-priority sources for collection include hard drives, electric vehicle motors, wind turbines, consumer electronics, and industrial motors. Commercial-scale recycling facilities and infrastructure are advancing, led by players like Cyclic Materials, Recycleforce, and Ames National Laboratory, though feedstock consistency and supply chain integration remain key challenges. Barriers to recycling include coatings and assemblies that hinder recovery, limited design for recycling in electronics and automotive manufacturing, and the need for scalable domestic separation and metal-making capacity. A multi-stage process is required to turn end-of-life magnets into usable magnets, spanning collection, chemical separation, and metallization, with a gap between recovery and remanufacturing. Pathways for recovering neodymium, praseodymium, and dysprosium are clearer, while other elements remain less viable with current technology and economics. Market acceptance hinges on quality and certification standards for recycled rare earth materials, covering chemical purity, magnetic performance, physical properties, and traceability. Advanced chemical extraction methods aim to selectively dissolve rare earths with lower environmental impact, but coatings, complex assemblies, and contamination hinder deployment. Hydrogen-based processing offers potential energy savings for recycling magnets, but requires further validation and scale-up. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.